Hello, good evening, and welcome to EU Training's online webinar, A Beginner's Guide to Abstract Reasoning Tests. Before we begin, I'd just like to introduce myself. My name is Robin Bott. I am a Chartered Occupational Psychologist, and I specialise in assessment methods, so abstract reasoning tests, as well as verbal reasoning and numerical reasoning and situational judgment tests. I've written hundreds of these types of questions over my many years, and I've also checked and amended hundreds more. I also do training on the design of different online assessments, how to use them, how to get the most out of them, and also how to perform to your best on those. And tonight I'm being supported by my co-host Lenka, who is going to be supporting technically, and we also have an email address for any follow-up questions following on from the webinar. So the aim of the webinar is to help you perform to your absolute best when you take the abstract reasoning exam for EPSO. The webinar itself is recorded, so you can review it afterwards if there's something you don't quite understand and you want to go back to, if there's something I discussed quite quickly, and you want to kind of go into a bit more depth, you can always listen to the recording as well. I'm going to give an overview of abstract reasoning questions, and then I'm going to talk about how they're built up, so how they're constructed by test writers, and how you can use that to your advantage. And particularly I'm going to talk about an approach of spotting patterns and using that to eliminate answers. I am going to be running through quite a lot of different rules, different what we call building blocks as well. So there's a lot of different content. So rather than kind of one necessarily overarching model that helps you solve it, I'm going to demonstrate a lot of different tricks, a lot of different ideas that can be used in abstract reasoning. Now this is actually complemented this session by an add-on pro session which runs separate from this. It's where we put what we learn in this session into practice. So there's going to be example questions and a chance to ask me questions as well. This is a very static webinar, so you won't be able to have any input into this beginner webinar, but once we get onto the pro webinar, you'll be able to have a bit more interaction with me, as well as really start to think about questions, have a go at a lot of these questions under sort of timed conditions. It does require purchase, but there'll be time after this webinar to purchase the pro webinar if you are interested. So an overview of the administrator abstract reasoning assessment. So this is focused mostly on administrator, but a lot of the skills can be used at assistant and linguist level. So it's a 20-question test, and you have 20 minutes. So that equates to about 1 minute per question. That means that some might take a bit longer, some might be a bit quicker, but the general rate you want to be working through is at about 1 minute per question. There's a pass mark of 50%, so half of the questions, but you want to be scoring as strong as possible on this to really show off your best. Now, the abstract reasoning is not based on existing knowledge, but instead it's based on your ability to work with unfamiliar information. Now, if you've seen a verbal reasoning and numerical reasoning, it might be a bit more obvious why these are used, and you might think to yourself, well, abstract's a little bit, well, abstract, what does it mean? How does it relate to the workplace? But studies show that well-designed abstract reasoning tests extrapolate to how quickly you can pick up and work with unfamiliar information in a role as well. So, so if you're quick to work with these abstract concepts, you might be quick at things like following flow charts, understanding complicated diagrams. You might be good at working in spreadsheets, for example, which aren't all about numbers. So it measures an important skill, and that's why EPSO chooses to use it. I said it's not based on knowledge, so you don't need principles. So there's not going to be, for example, I guess a crude example of a sort of principle-based question that you might expect might be a set of scales, and you're trying to figure out how they balance up with different objects on them, and you need understanding of physics and gravity to do that. That's not what we've got here. We've got much more simplistic concepts. You can't take a calculator in with you, but it is not required in order to work through. Everything you need will be provided. It's a good idea as you're working through eliminating answers to keep track of which answers you've eliminated, but that's kind of that's kind of about it. So before we begin, I just want to show you an example question. So I'm not asking you to solve this. What I want to show you is what an abstract reasoning question, an EPSO abstract, because there's many different forms, what the EPSO one looks like. So we have essentially a sequence here: step 1, step 2, step 3, step 4, step 5, or I sometimes call them frames: frame 1, frame 2, frame 3, frame 4, frame 5. You've got to figure out what comes next in the sequence. So there are 5 answer options presented. There's no sequence here, they're just 5 different answers. And you've got to pick which of them is the correct answer. And as I said, there's 20 of these, so you have to do this 20 times. So how we're going to talk through this tonight is, firstly, I'm going to talk about building blocks. Building blocks are what underpin all of these questions, and don't worry, as we're going through this, I should say, don't worry too much about the terminology. So I'm going to use terms like building blocks or rules or interacting rules or whatever. Don't worry too much about remembering the names of the rules. Just try and get your head around what's being described by them, the underlying concepts. But anyway, one we'll use a lot is building blocks, and I'll probably use that interchangeably with rules, to be honest. I'm going to give you an overview of what those are. Then I'm going to talk about them in a bit more detail, and I'm going to give you a list of different building blocks that can use to put together and pull apart for you abstract reasoning question. Now, we can't give an exhaustive list because there's all sorts of different rules that people come up with at different times, but we want to give you quite an extensive list. We really want to give you that good insight into the sorts of things that might be asked. More complicated techniques, it kind of builds on using building blocks. So we're going to give you some more complicated, so looking at how building blocks can interact with each other, or how they can be a bit trickier than they first seem. And in tips and tricks, I'm just going to give you some general advice. So these 3 sections, the first 3 sections are kind of linked to each other, and the final section, tips and tricks, is more broadly kind of how do you tackle it, how do you go about picking your answer, not just figuring out the building blocks. So, as I mentioned, we're going to start with building blocks, and I'm going to show you some building blocks separate to each other here. So looking at these are probably straightforward to understand. So this is an example of a building block, and the building block is essentially a rule that says each step, 1 more line is added, 1, 2, 3, 4, 5. And that's probably quite obvious. You probably look at that on its own and think, yeah, I can see that. This building block is just a circle moving between the left hand and the right hand side, staying in the bottom corner. This building block is a little bit more complicated, but it is essentially a set of triangles and a space moving to the right, and when it gets to the right, moving back to the left, continues to move to the right. So this is what these are the elements that underlie a question, and I'm going to combine them. And you're probably going to think, having seen them separately, it's quite easy, but it's possible if this was the first thing you saw, it can be a little bit overwhelming when there's lots of rules interacting. So for example, you can see that one rule is covering up another rule, and that might make it a bit tricky. Your task then is therefore to understand each individual building block, and that's how you can work out the answer the most efficiently. So if you look at this as a kind of complex set of different rules, what's the answer? That's going to be, what's the answer immediately? That's going to be difficult. But if you say, well, I can use the fact that it's really easy to work out this rule, I can use that to eliminate some answers, then I can try and figure out what's going on here, and eliminate some more answers, and here, and eliminate even further answers. One way of doing that, in fact, which I want to bring up immediately, is just, for finding a rule, is just comparing frames 1 and 2 and seeing the differences. So very quickly here, I know this is a very obvious one, this top row rule, but looking at this and then looking at this, you see this goes from 1 to 2, so another line has been added. And then you can look to 3 and see if, or frame 3 and see if another line has been added here, and it has, and it has, and it has, and that's how you get your rule, particularly with more complicated rules. So I'm going to go back to the example question we had beforehand and pause for a few seconds, and maybe just having explained that there's underlying rules and that they're usually reasonably simplistic has helped make this slightly easier already. I'm now going to break it down into its constituent building blocks. So let's look first at what is happening to the circle. So we see the circle is moving slowly round the outside edge. So in this stage it's at, well, I guess 130, it's top right. It moves around an eighth of a circle, or the eighth of the outside circle. Here it moves around the eighth of the outside circle again, another eighth, and another eighth. Alternatively, you could view it as moving between space and the line, and space and the line, and space and the line. Having seen this, we can figure out what the next answer option is going to be. It's going to move another eighth of a circle around. So we can use that to eliminate two answer options. Now what you might realise here is, even if this was the only rule, even if this question was much more complex, but then you had just this one particular rule that you figured out, you've already increased your chances of guessing from 20% to 33% by eliminating these two answer options. Another thing I want to point out is that if you saw the rule and you said the circle rotates clockwise, these two answers are technically correct as well. So there's an important part of the distance it rotated here as well, which is what lets you rule out these two. See, it's rotated clockwise, but it's rotated 2/8 of a circle, or a quarter of a circle, rather than 1/8 of a circle. Let's look now at the triangles, and this is an even more straightforward rule, but again, it can get lost in the complexity. So look at the triangle. What's it doing? Well, it's simply moving between the bottom right and the top left, the bottom right and the top left, the bottom right and the top left. So here we've eliminated another answer option. If you remember back, we'd eliminated, I think, C and D. So just by spotting the two rules, we've already increased our chances. We know it's A or B, and that's increased our chances from 20% chance of getting it right to 50%, which is the pass mark, if you'll remember. So if you can figure out 2/3 of the rules consistently, then you may well be able to pass the test. However, we don't want to do that. We want to get the correct answer. So we're going to look at the A and B again. There's only one difference between them now, and it's this square here. So that tells you that there's going to be something with the square that's going to tell you what the correct answer is. So the square is essentially moving anti-clockwise around the kind of inner section of the cross here. So it moves from top left to bottom right to top right. And so it repeats again, and this tells you that it's going to be in the bottom left next, which lets you eliminate, well, a whole host of answers, B and D. And given the other elimination rules, you now know that your answer has to be A. So this is what it looks like. The green shading is something, I should say, that we've added just to illustrate this. You'll never see green in the EPSO exam, but we've used it to show this is the only place where all three rules are consistent, are successfully and correctly completed. You might be noticing as well that the process, therefore, of figuring out what your correct answer is actually more tricky sometimes than figuring out the rules. That's why we recommend making a note of which ones you eliminate as you go along. So once you've worked through the first rule, once you've figured out where the circle should be, make sure you don't pick C and D. So cross it out or make a note of it. I sometimes even put my hand on the screen to cover up answers I know to be incorrect, and then I move on to the next rule. That means that something that's a complex process where you have to hold quite a lot in your head at once can become quite simple. This is the focus. This is the look at each building block, at each rule, one at a time, and use it to eliminate answer options. And that is the most straightforward way of solving these questions. And there's our answer there. So I want to talk a little bit more about building blocks. Now you understand, hopefully, what I'm talking about when I talk about building blocks. So there's going to be a lot of building blocks in a moment. Firstly, questions that EPSO use will generally be between 2 and 4 building blocks deep. So you wouldn't normally have one building block. That would be one rule that entirely dictated the answer. And the reason for that is it could be too easy, or if it's kind of a very clever rule, it's reliant too much on a bit of a eureka moment, a bit of a, oh, I suddenly get what's going on here. And that's not what they're looking for. They're looking for the fact that you can manipulate these different rules at the same time. Now, why they won't have more rules is to do with the number of answer options. So we have 5 different answer options. And when you think about it, if a rule is going to be useful, if it's not going to be redundant, it's going to give you, it's got to tell you, it's got to let you eliminate one answer option. So if there are 4 rules, the first rule is going to help you narrow down from 5 to 4. The second rule is going to help you narrow down from 4 to 3. The third rule is going to help you narrow down from 3 to 2, and the fourth rule is going to help you narrow down from 2 to 1. Sometimes they let you narrow down a lot more, but you know, at the very, very kind of at the very, very least, each one should be helping you learn something. So having that final rule, that 5th rule, would be completely useless. You wouldn't need to figure it out. So in a way, it would kind of make the question easier to have lots and lots of different building blocks, because you just pick the ones that you can understand. So what I'm saying, again, is use the approach, figure out your building blocks one at a time, and use this to eliminate answers. And from there, see if you can figure out even more building blocks until you get it down to 1. Even if you don't get it down to 1, you're still probably in a better position to answer it. Now, you may not need to figure out all of the building blocks. So sometimes all of our examples have 3 building blocks. Sometimes you can figure them out with just 2 building blocks. Sometimes you don't even need to understand the rules and why a question's right. So you're not being asked to complete a sequence, like draw out what the answer will look like. Sometimes just knowing that an answer can't be right will be enough to help you eliminate it. So you know that 4 of the options can't be right. You don't know why the 5th answer option is right, but you know that it's the only one that can be right. So don't worry about fully wrapping your head around every single rule necessarily. I'm going to now talk about lots and lots of different rules. So some relatively straightforward ones. The first one is object rotation. So this arrow, I'm going to talk about, again, pair it up, look at frames 1 and 2, and you can see that the arrow is rotating 90 degrees clockwise. Now check it here, and it's rotating 90 degrees clockwise as well. Now arrows can rotate 45 degrees, arrows in questions I should say, can rotate 45 degrees, so they'd be pointing at kind of diagonals, kind of like that one now. They can move 60 degrees sometimes, so they're moving a sixth of a shape. They can move clockwise or anti-clockwise. Also, it might not be an arrow that's pointing. That's a fairly easy one to it might be, for example, a triangle, or it might be a really complicated shape, and you need to kind of process it a little bit more to really understand what's going on. Increasing number. Now, this isn't a counting test, so you're not going to have very complicated examples of this. What you might have is something that you might have 2 different shapes, then 3 different shapes, then 4 different shapes. They might then reset 2, 3, 4. What you're very, very unlikely going to have is kind of 10 plus tally marks here, and you have to count another thing to see whether it's got 11 or 9 or 10 to figure out what comes next in the sequence. Numbers should be kept fairly straightforward, and this isn't a numeracy test, and this isn't a counting test. There's not going to be any kind of crazy interaction as well, so it's not going to be kind of multiply the number of one object by another object. That's as I say, they're not looking for kind of really clever rules. They're looking for how you can combine relatively straightforward rules. So numbers can increase and decrease, but they're never going to get particularly high. Position rotation. So sometimes an object can rotate around a grid, or around, as we saw with our example, a little circle rotated around the outside of a larger circle. Now we've got this rotating between the 4 corners, but there's no reason it can't stop halfway across, for example. So top left, top middle, top right, middle right, etc. Again, it's a rule that can happen with kind of any shape. Sometimes it can interact with object rotation, which can be quite confusing. And it's quite a common one in order of kind of keeping track. And again, you can spot that by looking at the first 2 frames. And the final rule is shading. And here we've got a reasonably taxing on the eyes one. It gives me a bit of a headache. But we have lines going from the top left to the bottom right, then moving horizontal, bottom left to top right, vertical, etc. Now, it doesn't even have to be that complex. I mean, that's kind of rotation in itself. But it doesn't have to be that complex with the shading. It might just move between black and white shading in cells in different frames, or it might move between a couple of different states. So it might have diagonal lines, then black shading, then no shading, etc. Some more suggestions, some more rules, building blocks that we might see. So first is position in a grid. So here, this is moving to the right 1 every time. Your question here might be what happens when it gets to the right. We'll talk about that in a moment. Overlaying. So this one can be reasonably subtle. Sometimes it can be hard to spot, but it's not trying to be too sneaky. Again, the questions aren't about those eureka moments, those like massive insights, but they're about being able to kind of spot things reasonably straightforward and then apply them. But here you see the triangle moves from in front to behind, from in front to behind. Number of sides. This has the same problems, I guess, as the increasing and decreasing number of an item, in that once it gets too complicated, it becomes a counting exercise. So we might see the number of sides increasing or decreasing or alternating, but it's not going to get, you're not going to be kind of counting a 12-sided, you're not going to be counting a dodecahedron or whatever they're called, a 12-sided shape or 20-sided shape or something like that. It's usually going to be kept relatively simple. And reflection. And in this one, we've actually used diagonal reflection, which means that it's effectively rotated as well. But for example, this arrowhead here in the next frame could point this way instead. That would be one way of reflecting it. Or it could reflect this way, so the arrowhead's up here, the tail moves down here. The important thing to be aware of, this can happen with more complex shapes as well, and it can interact a bit more. So you might have a really complicated shape with bits jutting out, and you've got to think about how it reflect or rotate when it's moving from one to the other. Good thing about reflection as well is often you can see that if it's kind of repeating itself, you can just look at it as a sequence of alternating things. Some final rules I want to talk about. Size change. So this is where something gets bigger or smaller, very straightforward. Alternation. So sometimes there's no discernible pattern. So here we've tried to create some two objects that they don't kind of naturally progress. So it's not so much a sequence of progression as it is just a pattern. So it just changes from one to the other. And a bit beyond the alternation, so this is 1 2 1 2. We've created a 1 2 3 1 2 3 pattern here. So we have something in the top left, bottom middle, top right, top left, bottom middle. So the top right is going to be your answer in this simple pattern. Now, if you only have steps here, you might be a little bit uncertain as to whether there's a definite pattern. But because you have this fifth step, you can be really quite certain that this is the pattern it's hinting at. So I talked a bit about sequences when they got to the end. What I want to illustrate here, I guess the key concept is that the first 3 steps for each of these is the same. And the question is, what will happen when the black square gets to the far right? So it goes 4th, 5th, 6th. And there are different things that can happen. So it could possibly reset back to the far left. It could reverse, so 4, 5, 6. 5, 4, 3, 2, 1, or it could repeat. So it could be a mini pattern. So it could just be moving along these 3 here, and therefore here it goes back to the 4th, so back to where it was there. I guess this is important as well, because just because you spot one sequence there doesn't necessarily mean that the rule applies at another point in the grid. So here's what I mean by this is illustrated by this sneaky question. So here's a 5-step sequence and 5 possible answers. And if you look at the top row, you might notice that this kind of resets back. So the black circles, it's actually easier if you look at these 3. So it goes 1st and 2nd, 2nd and 3rd, 3rd and 4th. So we see it's moving to the side, and we can see once it gets to 3rd, 4th, it starts to wrap back around from the left-hand side. So you've got your rule here. Now let's look at this here. So it moves to the right. Yep, we agree with that. If it's using the rule above, though, this circle should be dark, not this circle. So within the same question, we have a different rule. In this case, it's moving between 3, 4, and 2. 3, 4, and 2. Just to make things extra sneaky, we have a middle rule where it's bouncing back and forth between the right and the left. So this helps us work out our answer, but it's very easy to see that first sequence and think, this must be what's applying to all of the different sequences in the question. Now, question makers are going to be sneaky when they create these as well. They are going to create questions where you see this rule and you think it applies to here, and therefore you think the correct answer will be it moving all the way to the beginning, like this or this, when actually it's not. You'll also have distractions at times as well. So in the top sequence, we have this Battenberg pattern, which tells you nothing, and as long as you can ignore it, you should be absolutely fine. Sometimes you'll have an arbitrary position of things. So this circle moves about completely randomly, or we've tried to make it completely. So to solve the question, you need to look at other elements, like what direction is the arrow pointing, and is the rectangle behind or in front of the circle? And sometimes you can have patterns that are unsolvable but are really tempting to try and solve. So in this question, the way this arrow pointing, we've made completely arbitrary in terms of there's no way to figure out what comes next. You can tell what happens to its shading. It goes black, white, black, white, black, white. And you can tell, if you're very eagle-eyed, if you're very quick, you might have noticed that it points to whether the pentagon will be in the next picture. So this tells you where the pentagon will be in the next frame, but it doesn't tell you what position. There's no way of figuring out what position the arrow will point in. So some of the more complicated techniques. So often you'll have rules that interact, so building blocks that impact the same shape. So very quickly here we have size, so this is increasing in size and moving. We have position and shading here, which is a circle moving along, reasonably straightforward sequence to spot, I think, and it's also changing between white and black. So you have to bear those things in mind. And we also have this arrow, which is moving around and also changing its own orientation. So the key here, to make it as easy as possible, is to try to break these into the underlying rules. So try here, for example, to look at where the arrow is and figure out where it should end up, and then separately look at which way the arrow is pointing and where it should end up. It's particularly confusing actually with arrows pointing and moving, because they often point in directions that you think they're going to move. So here it's pointing down, here it's pointing left, but here it's pointing up and it doesn't move there. So be very careful, try and break them down into the constituent parts. You might also notice here that all of these have position in, but that's just a common one, but it's not the be-all and end-all. So you might have an object that's rotating, and also its pattern is alternating as well. So it doesn't have to be position, but we've used that a lot. Now we have inconsistent rules. So I talked about looking at the first pair of items, first pair of frames, and seeing if you can extrapolate from that. So here, this moves 0. The circle stays in the same place. But look here, it's moved a place. So the rule we get from here doesn't work. Same here, it moves 1 to the right, but then it doesn't move 1 to the right because it would be here. How do you deal with these inconsistent rules when you see that the pattern you spot in the first few frames doesn't bear out? Well, one thing I like to do is look at what the change is, try and describe it. So here, what's happening in the first step? The frame 1 to frame 2, there's no movement whatsoever. Now look at frame 2 to frame 3, and it moves one place clockwise. And you can carry on filling it in like this, and you see a pattern emerges. So now you know that it's going to move 4 places clockwise to get to frame 6, which is your answer. Now these can be extra sneaky because sometimes they can evolve and change direction. So say in the first frame, the first frame here, this circle might actually be in this frame here. So it moves 1 anti-clockwise, then 0, then 1 clockwise, then 2 clockwise, etc. So what you've got there is essentially a sequence of -1, 0, 1, 2, 3. So if we apply this to all of our questions, we can see consistent patterns going through each of these. So the evolving rule, and don't worry about the terminology I'm using here, worry more about the concept of how to solve it. But we can see here, 1, 2, 3. Well, that's a very easy thing to figure out what happens next. 1, 2, 1, 2. Again, once you know that, it's very easy to know what's going on next. And 3, 0, 3, 0. So this is when a rule applies every other step. And it doesn't have to be a mathematical rule either. It can be something rotates every step, or it can be something changes shading every step. But if you spot that, then it will help you solve the answer, or that building block will help you eliminate rules. And interaction. So with interaction, you might have different elements, different building blocks interact again in other ways. So I discussed some earlier. Here are a few more. So pointing to a future location. So this arrow points here. Again, this arrow's direction is supposed to be quite random, quite arbitrary, so there should be no pattern to it. But what you can spot is here it points to the top right, and something happens to the thing in the top right in the next step. It doesn't even have to be the next step as well. It could be 2 steps on, so be very careful and look out for these things. Here it points to the bottom right, that disappears. This returns, that's just how we've designed the question. It might stay hidden. It might be the case that the arrow points in different directions and it loses blocks, and then suddenly when it points at a missing block, that block returns in the next question, in the next frame, for example. So all sorts of things can happen here. So be wary, because this is one you can't spot within the frame itself, and you can't spot it by looking at one element from frame to frame. But if you look at one element and you look at different elements and how they might interact, that's when you can start to see things. Covering. So here we have a simple sequence where a white circle is moving around the edge clockwise, and a black square is bouncing back and forth between the left and right hand sides. But once they get to the same part, the circle is obscured. Now this means that there's a little bit of extra complexity, because you have to think to yourself, well, where is the circle now, and where will it be in the next frame? A common mistake would be to put the circle in this frame for the next answer. Or sorry, put the circle in this square for the next frame, I should say. Now we've put this obscuring in the final frame of our sequence, but there's no reason it can't happen earlier or later. So if you imagine this sequence reversed, this might be your first image and you don't know where the circle is, and then you have this image and then this image, and you think, where does the circle appear from? And the key is that it's being covered, and you can work that out, and you can extrapolate, and you might have a hypothesis, and you can say, I think the circle will be here, but it's covered, but that makes sense because it's emerged in the next sequence. And when active is another final interacting rule that I want to discuss. So here we have a simple sequence where this black square moves from the left to the right and then resets back to the left. However, every time it moves into the big black square, the triangle flips upside down. So when this condition is met, the big square is shaded black. This triggers this condition here of this triangle flipping upside down. So again, it's something to be aware of. It's often in the form of when an arrow points at something, then something will happen. These are examples of complex rules, and we can't go into too much detail because there's all sorts of ways of them manifesting themselves, but being aware of what can happen is very important. Now finally, I want to cover some tips and tricks that are not so much related to the building blocks. So the building blocks are very, very important tool, but there are other ways to approach these questions. Firstly, I say no building blocks, and immediately I talk about building blocks. If a building block has 4 states, then it's going to help clue you into the answer. So an example, if you notice an arrow is rotating clockwise, it's pointing up, then right, then down, left, then up, then right, then down, then left. You can see that this is occurring. Steps 1 and 5 will be the same. So up, right, down, left, up. They're both pointing up. This means as well, if this is a true sequence, that step 2 will be the same as the answer. So just by looking at step 2, you don't have to work out the full sequence here, but you can still work out the answer just because you know that it's a 4-state pattern of progression. Now this can sometimes even help you solve full questions. So if you notice that the 5th frame and the 1st frame are identical, a lot of the time it might be that the 2nd frame will be identical to the answer. Another thing I should say, and this is quite common as well, because you're often kind of moving around the 4 corners of a frame, or you're often rotating in 4 different directions, or that sort of thing. Another thing I should say is that when I say 4 states, that includes two states as well. So if something goes black, white, black, white, black, white, black, white, then steps 1, 3, and 5 will be the same, and steps 2, 4, and the answer will be the same. My next tip is to review the answer options and see which choices are common, because that can help you eliminate answers. Now, this is definitely not the way to approach the question, but it can be a way to clue yourself in if you're not sure what the correct answer is. So here we've come up with a sequence, and we presented you with the 5 answer options. And because of the way the questions are constructed, you can actually get a very good idea of what your correct answer is going to be. So, for example, if the sequence ended in a white circle, you would only need one rule to understand it. So therefore, it's unlikely that the answer with the white circle is going to be correct. That helps you eliminate C. And you'll notice several similar rules. So the arrow pointing this way, eliminate answer A, because it's pointing elsewhere and everything else. The circle being on the right-hand side rather than the left-hand side, eliminate option D. And the rectangle being to the far right, eliminate option E. Now these are soft eliminations, but these can really help. So I think our answer was B there. This can help you narrow down, particularly when you're unsure what the answer options can be. Now, a lot of the time it's going to be a 3-2 elimination as well, and I have a lot less confidence in that, because sometimes there'll only be a couple of answer options that work with one rule, with one building block. But again, if you're stuck, if you need a bit of support, that can certainly help you figure out what is most likely to be the answer option. So try and understand the actual sequence itself and how to get to the answer. But if stuck, look at this. See if there's anything really obvious that helps you eliminate, soft eliminate answer options. Now, I've talked about this quite a few times, but compare pairs of frames to help spot patterns. So look at frame 1 and frame 2, look at the differences and see if those differences extrapolate to frame 2 to 3, 3 to 4, etc. Another thing which we talked about in the example at the beginning is if you have answer options, if you narrow it down to a couple of answer options, look at what differences there are between the answer options, and then try and figure out your correct answer based on that. So particularly when you've got a very busy grid with a few things going on, sometimes just by eliminating it down to 2 and saying, the square's in a different place between these two, that can tell you what you're looking for. You're looking for where should the square end up. Look for rules one at a time. So yes, there was some simple examples. So position, I guess we had a position plus rotation was something that you could probably work. You could probably combine those two rules and figure out your answer. But the best approach is to find a single rule, eliminate answer options, go back, find another rule, eliminate answer options. Just make sure you kind of take notes as you go along, so you know what you've already eliminated, and that will help you very quickly get to the answer without having to hold lots of very complicated combinations in your head at once. And the final piece of advice is to practice. So try and simulate test conditions wherever possible. So 1 minute per question, silent, don't have people helping you out or in the environment with you. Try and get as much realistic practice as possible. And that does lead me on to mention that if you attend the Pro webinar, you'll get a chance to practice these live and ask me questions and have a go kind of at building on these skills that we've done. But whether you attend the Pro webinar or not, I'd like to say thank you very much for attending the beginner webinar, and best of luck in your exams.